Hello everyone, this is Mr. DeMars, and I am going to go over the questions on the homework day 10 practice test. Now, a lot of you did this on the formative app, and I'm doing it on a text version here. So hang with me, but I am going to go over how we came to all the correct answers. All right, so while we check to see if these tables show proportional relationships, I remind you of two ways we talked about in class. One way is to find the constant of proportionality by dividing y by x, and that should stay consistent throughout the table. Or we can compare values, and I'll say more about that later when I show it. So, if I am using method 1, I can find my constant by dividing y by x. So 4 divided by 2 is 2. Now I'm going to check my second entry, second set of values. And I do y divided by x, 9 divided by 3, and I get 3. Now these do not match. And if they do not match, then this is not a proportion, or it does not show a proportional relationship. So this is not proportional. Okay, for this next table, I'm going to continue with find the constant of proportionality, y divided by x. So I have all my y's divided by all my x's, and I'll use a calculator and figure out what I get here. All right, so when I did 1.6 divided by 8 and all of these y divided by x's, I did end up with the exact same answer, and that's 0.2. So this table does represent a proportional relationship. It is proportional. Let's look at this table here and see if it shows a proportional relationship. Now, we've been doing y divided by x, 4 divided by 4 is 1. I just thought for fun, I know when I walked around the room, some kids use this approach. They said, well, if I can multiply x by the same thing and it gets me the appropriate y, or the same y, or the y in the table, it should work. So 1 times 4 is 4, and 1 times 5 is 5, and 1 times 6 is 6, and 1 times 7 is 7. This is a proportional relationship. And of course, we could go back to y divided by x, and 4 divided by 4 is 1, and all of these, when you divide them, will give you 1. So this table does show a proportional relationship. It is proportional. Now I know we're really good at doing y divided by x, but I did say in the beginning there are other ways to check this. And one way is to compare values. If I compare 4 to 20 and say to myself, what is my scale factor from 4 to 20, it would be multiplying by 5. So 4 times 5 is 20. So if I apply that scale factor to the other side, to 7, 5 multiplied to 7 is 35. Well, wait a second. This says 23. So this is not proportional. It did not, remember the double or triple or make it 5 times larger. They should all both the x and the y should be able to be multiplied by 5, and the numbers should show that. So question 2, we're supposed to sort these situations and be able to determine, are they showing a proportional relationship or are they not? Great strategy on your test is to use a table. That would be a really good strategy. And I did that quickly. I started with 50 pencils. Every week, students take 5 of them. So at week 0, I started at 50. And after week 1, now I only have 45. So remembering, in order to be a proportional relationship, it needs to satisfy the 0, 0, or to be able to go through the origin on a graph. So this is not proportional. Our next situation is I went to the store and I noticed that 1 pound of carrots will cost $2.99. 2 pounds of carrots will cost $5.98. So again, table, great strategy. We could find the unit rate. We could do y divided by x, or we could say, what do I multiply 1 by to make 2? I noticed a lot of students using this method. scale factor, so they multiplied this by 2. So then they said, well, all I need to do is make sure that $2.99 multiplied to 2 will equal $5.98, and it does. So it is proportional. All right, we're going to use a graph on this one. The height of lemonade in a pitcher is 25 centimeters tall. Every time you add an ice cube, the height increases by 2 centimeters. So if I were to do that, before I add the ice, it's telling me that it's 25 centimeters, which might be right there. And then each time I add an ice cube, I will go up 2. So there, I'll just keep going up. Now again, it is a straight line, but did it start at 0, 0 in order to be proportional? No, it started at 25. So this will be not proportional. It is not proportional. All right, the last one with the sprinkler. Sprays water at a constant rate of 12 gallons per minute. That's 12 gallons for each minute. Well, if I make a table, I'm going to see that 0 minutes, no gallons, it's not on. Now 1 minute will be 12, 2 will be 24. Yes, it is proportional. All right, so now we're going to look at equations and see if we can tell if they show a proportional relationship. One good strategy is back to that table. You make up an x value, plug it in, 0 divided by 2. That does, if you use a calculator, you get a 0. It is 0. And if you do 1 divided by 2, that's 0.5 or 0.5. And 2 divided by 2 is 1. So a proportion should fit the 0, 0 rule, and you should be able to double it. And if I double 1, I get 2, and if I double 0.5, I get 1. So this first one is, yes, proportional. On the next one, I'm going to go right away to our 0, 0 rule and try that. I'll put a 0 where x is and a 0 where y is. Well, 0 divided by 0. Remember, we're not allowed to divide by 0 or have it be in the denominator, and that would be an error. And even if you did think this equaled 0, it would make this equation unbalanced. 0 does not equal 54. So this is a no. It is not proportional. Now again, feel free to do a table, but a lot of you are like, Mr. DeMars, no, remember? Adding, we cannot add this. If you graph that, it would start at 6, and you're totally right. So because it has addition, that's a no-no. This will not be proportional. And again, if you'd like to make, if we did plug in 0 for x, and 0 multiplied to 5/4 gives us 0, and then if we add that 0 to 6, we would get a y of 6, and right there, 0, 6 would not fulfill the 0, 0 rule. Some of you are also like, oh, I also remember exponents will not work. Exponents will not work. So this is going to be a no also if the variable, if x or y, has an exponent. Just in case here, I did do a quick table, and the 0 does work, but 1 to the second power is 1. 1 times 7 is 7. 2 to the second power is 4. 4 times 7 is 28. And if I did the doubling rule, I double 1 to get 2. If I double 7, that is not 28. That is a no. All right, the last two, we can make a table, but if I put a 0 in for x and go in order in the calculator and do 5 divided by 0, it will say error. And in math, we call this undefined. You're not able to divide by 0. So this, if let's say you wrote down 0 and kept going, it still does not match the pattern of what do you times 1 by to make 5? 5, and 5 times 2, if that's our constant, should be 10, and it is not. So this is a no. All right, well, we usually make up x's, but you know what? You can make up y's in your table. And if we do 0 right here, 0 times 8, we do sure get 0. That works. And if we do 1 multiplied to 8, we get 8. And then if we come here, we say 2 multiplied to 8, we get 16. And let's see, 0, 0, yep. And if we double 1, we get 2. And if we double 8, we get 16. So this is going to be a yes. This last one is proportional. All right, students, you are very good at this skill. I've seen it. Looking at a graph, remember those two things we need to see in a graph. It needs to be a straight line and go through the origin, or 0, 0. So this is a straight line, but it's not going through 0, 0, so this is no. This is a straight line, and it is going through the origin, 0, 0, so this will be yes. Here we have another straight line, but it did not go through 0, 0, so that's a no. And this one down here sure looks like a yes. It's a straight line, and it is going through the origin. All right, question 5. In 1 minute, I can read 300 words. At that rate, how many words can I read in 15 seconds? Well, something I noticed right away, they're talking about seconds here, and they started by talking about minutes. So I need to convert my 300 words per minute and figure out how many seconds are in 1 minute. And if we think about that, there are 60 seconds in a minute. So I am going to not use this red ratio. I'm going to use the blue one. And then I'm going to try and figure out, well, how many could I do in 15 seconds? So what I can do is I can write 15 seconds here. Think of it like a table entry. And let's go back to our scale factor from the scale unit. What are we doing to 60 to make it 15? And if you use the hint, it says 15 seconds is 1/4 of a minute. So what we're actually doing is we're 1/4ing it. You could say divide by 4, that's the same thing. So we are doing 1/4 of 60, and that is 15, or 60 divided by 4. So if I were to do 300 divided by 4, I should figure out my words. So if I do 300 divided by 4, I do get 75, and that means in 15 seconds, I will be able to read 75 words. And so I'm just going to write 75. I'm not going to write this because I have to answer the question. The question said, how many words can I read? And that would be 75 words. Question 6 continues the situation. And if we remember back to question 5, we did have to convert our words per minute to words per second, and we figured out that 60 seconds is 1 minute. So what I'm going to do is find my constant. So I have my y and I have my x. I'm going to divide these. 300 divided by 60. Now, if I were to reduce that, I could cross my zeros off, and I could say 30 divided by 6, and I get 5. Well, I'm going to look at my labels. That means 5 words. I have 5 words per 1 second. So that's my rate. I can read 5 words per second. So now it said, write an equation. Some of you are thinking, well, I don't know how to write an equation. Okay, go back to what I said in class, talking about my math teacher, Mrs. Mack. If we were to make a table and we were to say, what am I doing to x, or in this case, s seconds to find the words? Why? Well, what am I doing? I am multiplying each one by 5. 5 times 0 is 0. And 5 multiplied to 1 is 5. 5 multiplied to 2 is 10. 5 multiplied to 3 is 15. Mrs. Mack always said, okay, what are you doing each time? Write that in your equation. And I was multiplying by 5. Now Miss Mack said, go back and put in variables and an equal sign. Well, I multiplied 5 to all of these numbers in the S column, so I am going to write an S, and my S's sometimes look like 5s, I'm sorry. Then an equation has an equal sign, and Mrs. Mack said, use variables. So instead of writing these numbers, I'm going to use a variable of W for words. Another way you could write it is you could start with W and say W equals 5 multiplied to S. That is, that's a bad S. Let's try this. There's a better S, but my S's sometimes look like 5s. I am sorry. But either of these work. 5 times S equals W, or W equals 5 times S. All right, question 7. All right, to make a shade of green, Grace mixes 6 cups of blue paint with 5 cups of yellow paint. All right, so I made my 2 tables. This table will be for the first question, and this table will be for the second question. And I like my tables. It's just a good visual way of seeing it. So I set up with 6 blue to 5 yellow. There's different ways you could do this. But doing a scale factor is a solid way. We could draw a line and say, what do we do to 5 to make it 1? And that is times by 1/5. Or we could say divide by 5. 5 divided by 5 is 1. Whatever we do to the yellow, we have to do to the blue to keep it proportional. So we're going to have to do 6 divided by 5. Okay, so we're going to do 6 divided by 5. And when we do that, we get 1.2. So the answer to this one was 1.2 cups of blue. All right, for the second question, we want to find out how much yellow paint we would need if we had 15 cups of blue. So on this one, we're going to use the scale factor, or I'm sorry, I back up. We're going to use the constant and ask ourselves, what do we multiply 6 by to make 5? And to find that, we can do y divided by x. We can do 5 divided by 6. And 5 divided by 6 is not a very nice decimal. No, it is 0.8. And then we have some 3's that just keep going, so we can put a line over it. So if you're using a calculator, a good strategy would be to do 5 divided by 6, leave that answer of 0.833 in your calculator, and then multiply that to your number, to 6 in this case, and when you do that, you end up with 5. So I'm going to use this constant of 5/6, which is equal to 0.833, and I'm going to take that, I'm going to multiply that to 15. When I do that, when I multiply 5/6 to 15, I do get 12.5. So we need 12.5 cups of yellow. All right, question 8. Each proportional relationship has 2 constants of proportionalities. Match the pairs of constants together. We have done activities in Desmos and on the assignments, and we've explored proportionalities enough that we figured out that depending on if you're going from x to y or y to x, there is a relationship between those constants. And if you remember, they are called reciprocals. Okay, so one strategy was recommended that you could divide 1 divided by the first constant will give you the second one. So we could use that. What I suggested to a lot of my students was to write all of these as fractions, and then over here, or next to them, we will write the reciprocal. So that is what I did. I took 2/3, and I knew that the reciprocal is 3/2. And 1/9, if I were to flip that, or do the reciprocal, I get 9/1. 4/7 will be 7/4, and 0.5, I knew that that was 1/2, and if I were to do the reciprocal or write that, it would be a 2/1. Now, I'm going to try and match these red numbers here to these. So let me look here. Let's do this. All right, I see 2/1 could match right there. So that should match. Then I see 9/1, okay, and that's the same as 9. So now I have to think, where will this one go? Well, I'm not sure if it equals this, but I know that if I look at 3/2, this is 6/4, and I'm thinking another form of the fraction 3/2 that it can take is 6/4 if I doubled the top and the bottom. And let me check. Yep, that will match. And then 7/4, my last one, if I were to do 7 divided by 4, I would get 1.75, and sure enough, that will match. Question 10. A plane can travel 40 miles in 5 minutes. What does the constant of proportionality, 0.125, represent in the situation? All right, great hint here. Try to figure out, how did they get 0.125? Did they divide the miles by the minutes or the minutes by the miles? I think that's where we start, right there. Well, right away my brain was like, hey, I'm going to do 40 miles divided by 5 minutes and find the miles per minute. And 40 divided by 5 is 8. And so that tells me 8 miles per minute. Guess what, though? 8 is not equal to 0.125. All right, so I need to do 5 minutes divided by 40 miles. If you look, it's the reciprocal of the red ratio that I wrote over here. So I know that 5 over 40 is 1/8, or I could just do 5 divided by 40 or 1 divided by 8. I get the same decimal. It's 0.125. Okay, yes, it matched. So now I have to put meaning to this. Well, my numerator was minutes and my denominator was miles. So that means that my 0.125 is minutes, and that's a rate of 0.125 minutes for every mile. If I look at my choices here, the plane takes 0.125, what's my label say, minutes to go 1 mile. Question 11 is about some pears at a grocery store. I know that some students had a difficulty with the picture, maybe not showing up on formative. So it is a good thing that we're going over this. It says that there are 2 types of pears at the grocery store, store A and B. And which type of pear is more expensive, A or B? Now, what's super important in this question is, how did they label the axes? So on X, they put cost, and on number of pears, they put that on Y. A really good strategy is to draw in a number on the X, and a great number to use is 1. So for $1, okay, so for $1, how many pears do you think you could buy? So you got to make this up. So I'm going to make that up. I'm going to say maybe 2 pears. Now, that's for line B. Line A it looks like this dot is higher. This point is higher. So we need to pick a number bigger than 2. So you might say 4 or 3. So let's say 3. All right, if I look closely here and I put it in a table, all right, line A, for $1 I get 3 pears. For B, $1 I get 2, and it's asking which type of pear is more expensive. That's why it's so important to look at how these are labeled. All right, so if we look at this, B is a more expensive pear because you can get less pears. You can buy less pears for $1, meaning each pear costs more because you get less of them for your $1. Where A, you can get more pears for $1, so they must be more inexpensive, the cheaper. So which one's expensive? B. Question 12. Plot the line of this graph. And it says y equals 5/2 multiplied to x. Well, one strategy is to convert 5 over 2 to divide them and get 2.5. So you could use the equation y equals 2.5x. The hint was to think of 2 values, a value for x and a value for y, that would make this statement true. One one way to do that is to generate a table. Well, we could come up with x values and plug them in to get y values. So if I were to do 0 for x and put a 0 right here, and I multiplied that to 2.5, 0 multiplied to that gives me a 0. Okay, so I could plot 0, 0. Then I could put a 1 in for x and multiply that to 2.5, and I would get 2.5. So I could go over to 1 and go up to 2.5. Then next, I could put a 2 in here, so I could put a 2 where my x value is, and multiply that to 2.5, and then I would get 5. So I could go over to 2 and up to 5. All right, on formative it looks a lot nicer, but if I use a straight edge and connect these, I do form a line, and sure enough, looks like a proportion. We start at 0, 0, go through 0, 0, and it's a straight line. All right, let's start with question 13 here. It says the equation of this line is W equals 9/8 multiplied to N. W will stand for the weight of a notebook or notebooks, and N is how many notebooks you have, the number of notebooks. So again, like the last problem, I could convert 9/8 into decimal form by dividing 9 by 8, and I get 1.125. So I replace that in the equation. Now I'm going to generate a table. So I'm going to explore. If I have 0 notebooks, that should be 0 weight, 0 multiplied to this. 1 notebook, 1 multiplied to this number gives me 1.125. So 1 notebook weighs 1.125. And then I'm going to put in a 2. So I'll do 2 multiplied to 1.125. And that gives me, if I multiply that, I get 2.25. Now let's explore some of these statements and find out which ones are true. All right. The weight of 1 notebook is less than a pound. Okay, so if these are pounds, no. 1 notebook is more than a pound, so I'm going to say no. 2 notebooks will weigh 2.25 pounds. Let me check my table. 2 notebooks, I doubled these. Yeah, I'm going to say yes. That looks like a good one there. So we're going to say yes to that one. All right, the next one we're going to look at is 8/9 represents how many notebooks weigh 1 pound. So when I read that, I thought, I'm going to change my table and flip it around and put my weight here in notebooks, and I'm going to come up with a weight of 1 pound. So what I did was I just transferred my values over here, and I said, what do I multiply 1 by to get this? And that's 9/8. And 9/8 multiplied by 2 is this. If I change it or flip it, I'm going to use the reciprocal. So 8/9 multiplied to this does give me back to 1. And 8/9 multiplied to this gets me to 2. So if I do 8/9 multiplied to 1, I get 8/9. And let's go back. 8/9 represents how many notebooks weigh 1 pound. So 1 pound will give me 8/9 of a notebook. So I'm going to say yes to this one. All right, our next one we need to check is 9 notebooks weigh 8 pounds. Well, I used my table, 9 notebooks. I'm multiplying by my constant of proportionality. And when I multiply that, I end up getting, on a calculator, 10.125. And that is not the same number as 8, so I'm not going to check that one. Well, using that same method might help us discover the next one. It says the point 16 and 18, 16 for x and 18 for y, is on the line. Let's see if that's part of the table. If it's on the line, it will be in the table. So I put 16 in for my x value, or my notebooks, and I multiplied it, and when I multiplied it by my constant 9/8, I did get 18. So if I look here, 16x, 18y, I'm going to say yes, that one works. Last one we're going to check. A truck with a weight limit of 88,000 pounds, could it transport 80,000 notebooks? So I'm using my table again, and I'm going to use my constant of 9/8 and multiply that to that 80,000 so I can figure out how much 80,000 notebooks really weighs. Well, if I do that, it weighs 90,000 pounds. And the truck can only hold 88,000, so I am not going to check this because it would be a no. It will not hold it that much. All right, question 14. This graph shows a person's walking speed. On X, we have time in hours. On the Y-axis, we have distance in miles. Write an equation to show the relationship between distance and time. Use M for miles and H for hours. All right, so I used my table, and to find my constant, to find out what am I multiplying 4 by to make 15, remember, you can always do y divided by x. To find your constant, you can always take your y value and divide it by x. So we're going to go 15 divided by 4, and we get 3.75. What does that mean? Well, it means that we were multiplying 4 by 3.75. It also means that it's 3.75 miles. Okay, that can travel, this person can walk 3.7 miles in 1 hour. So in 1 hour, they can walk 3.75 miles. Now, thinking back, how do we write an equation? Mrs. Mack, my math teacher in 8th grade, said, well, what are you doing? What are you doing each time in the table? Well, I'm multiplying by 3.75. So Mrs. Mack would say, write down what you were doing every time. And so I was doing 3.75. I was multiplying something. Well, what were you multiplying? Let's see, 1 and 4, but those represent hours. So I was multiplying hours. So I'm going to multiply that to H. Then use an equal sign to make sure it's an equation and not just an expression. And then we got answers here, but what column, what were these numbers representing? And they were representing miles. So I'm going to go back and use a variable m. So let's check this out. Miles equals 3.75 multiplied to my hours. And that equation should generate this graph. All right, I hope this helped. Feel free to go back and pause or rewatch any of this, and good luck on that test when you take it. Take care.